Voegtlin, the main developer of Electrum, and I'm going to present our efforts implementing the Lightning protocol. So this is work that we started a year ago, and we are not close to a large audience release, but I mean we are kind of feature complete now. We are just fixing bugs. And yeah, so this is my PGP fingerprint. It's important, so I try to display it every time I give a presentation. And you can find a copy of these slides at this address. Yeah, so if you do verify the PGP signature when you download Electrum, it's also good to know that if you download the fancy Bitcoin ticker that displays fireworks when it goes over 9,000, you should also verify who ships you this application, because it can steal Bitcoin addresses from your Electrum wallet. I mean, any software that you run, not just Electrum. Okay, I'm saying this because we've had some phishing issues recently, and people are asking a lot about the safety of software and how to verify keys. So on your system, any piece of software can misbehave. It's not only the Bitcoin wallet that has to be safe. Okay. So I started Electrum because I believe that light clients are needed. Some people want everybody to run a full node, but actually my view is that the safety of the Bitcoin network is also dictated by the price, because the price of Bitcoin is what is going to affect the hashing rate. And the price requires a large user base. So if you want to achieve that large user base, you need light clients. I guess today it's kind of easier to say these things, but at some point it was a bit difficult. So our goal is to create light clients that are as safe as possible in order to compete with websites, whether they are custodian or not custodian. I do not have a preference between custodian and non-custodian websites. I mean, if you have your Bitcoins on a custodian website, actually there is somebody that you can sue, hopefully, if your Bitcoins disappear. Whereas if it's non-custodian, they can always claim that you never had those Bitcoins. So be careful about that too. Yeah, so our goal is really to provide the same experience, but without the dangers of a website. So Electrum was started in 2011. That's quite an old project. It has received contributions from hundreds of people at this point. And the main features are that you own the keys. You are also kind of safe from your own mistakes, because the wallet is deterministic. That means that you can restore your funds from the seed. And this is going to be a problem with Lightning, because our users have been trained to think that they are always able to restore the wallet from the seed, which is no longer true with channels. But I will talk more about that later. And so Electrum is as fast as a website, because it uses this client-server architecture that is not trusting the server, because it's verifying what the server sends. So with Lightning, it's a new universe for wallets. Like I said, you cannot restore from seed, so Electrum users will have to learn that. And we will have to be careful about educating them about that. You have new constraints about routing and liquidity instead of scaling on the blockchain. You need to watch your channels, because if the other party closes the channel, then you need to be there to claim the funds. And you need to be online in order to receive payments. So all these points, all these 4 points that I mentioned, they are going into the direction of using a custodian service, because custodian services can address these points more easily than we can. They can take care of backups. They can back up your data. They can take care of liquidity without showing you how many channels you have. They will watch your channels for you. and you can receive funds while you are offline, because they are always online to fulfill the invoice. So they can give you an invoice, and then you can give that invoice to someone else at any moment, as long as it's not expired. And you don't need to be online to receive funds if you have somebody who is online for you. So these are the challenges for us. I mean, we need to compete with that. Okay. So our Lightning implementation is, so this is a screenshot from GitHub. We have about 800 commits now. And like I said, yeah, we started this effort a year ago. It's a pure Python implementation of the protocol. I mean, it uses some libraries, of course, that are not Python. Yeah, Electrum itself initially started as a pure Python project. Even ECDSA was implemented in Python. But now we are using libsecp 256. So it's also better for Lightning to use this library, because it's faster and it's protected against timing attacks. So this Lightning branch, hope, will be merged soon. That doesn't mean that we're going to release soon, but we will merge it in master soon. It will not be enabled in the binaries for a longer time. But at least we will have more user feedback if it's merged into master, because some people use the master branch of Electrum. So this is how the GUI looks like. So it has a new tab that shows you your channel. So yeah, this is kind of an old screenshot, but I have prepared a few demonstrations. So I'm going to switch to demo mode. First, I'm going to explain you how this demo runs. So it's going to run on regtest, because I want things to work. on mainnet also, you need to wait for block confirmations, and there are way too many things that can go wrong. So you need, I mean, on this local machine, I have BitcoinD running, I have LND, and I have Electromix. Electromix is the software of the Electrum server. And so you need to check out the Lightning branch of Electrum. Actually, if you are watching this presentation online, you can redo the steps that are on this screen, and you can fairly easily reproduce everything, because everything is on the screen, everything that I'm going to do, except the setup of Bitcoin CLI and LN CLI variables. I mean, this will depend on your system. They just need to be set up for regtest. Okay. So yeah, what I'm going to do here is I will have Alice and Bob. So these are two Electrum clients that run with the -- Lightning option. So this is the option that you can currently only have from the command line, and that will enable Lightning in Electrum. So once we merge this into master, it doesn't mean that it will run automatically. You will have to type this option from the command line, and therefore by default it will not be enabled in the binaries for Windows or Mac. -D is the directory of your Electrum folder. So this defines your identity. Alice has this folder and Bob has this folder. And so both users have a completely different identities through this, even though they are on the same machine. Okay, so let me do that. So I have a script that skips the first steps of the. So this is actually creating Alice and Bob, the two wallets, and it's also funding them. So that now I can show you two terminals, one for Alice and one for Bob. Yeah, okay, so I hope I didn't forget anything. So Alice is here. So it's a fresh new wallet that is funded with 1 regtest Bitcoin. And Bob is going to have the same. I'm going to set up the theme to dark for Bob. I must have this common in my history, so that we can easily distinguish between Alice and Bob. Yeah, okay. So setConfig is the command that sets a configuration variable. So now I set Bob to dark. And let's start Bob next to Alice. Okay. So you have Bob on the right and Alice on the left. And I'm going to open channels with the LND instance that will be in the middle. So LND is going to relay between Alice and Bob. For this, I need to request the node of LND. So, okay, I can. Okay, so this is LNCLI get info, and this is the node ID of LND. So, of course, if you're on mainnet, you can connect to a random node, but with reg tests, you need to open the channel manually like this, and you type the remote node ID here. So I want those channels to be balanced, so I'm going to have 10 millibitcoins on each side. Okay. So I do the same here for Bob. So we open channel with LND. And this is how you do. Okay, so now you can see that those two channels are in the status opening.
Can you show the history of Alice?
Yes, sure. History of Alice has, so, well, this is Bob actually. Alice is on the left. So Alice has the funding transaction, and then this channel transaction is the funding transaction of the channel. So it's taking 20 millibitcoins from the on-chain balance, and it's sending 10 millibitcoins on Alice's side, because I said earlier I want the channel to be balanced, so there is 10 millibitcoin on each side. Okay, maybe I should make this screen a bit larger, like here. So you have two extra columns when you start to enable the Lightning option. You have your on-chain balance and your Lightning balance. We could actually merge those two columns in the future, but yeah, that's minor. I mean, that's GUI work. That's not what we're doing now. Okay, so let me mine a few blocks. Yeah, very easy. So I need 3 blocks here. And let's see, you will see here that the transactions have confirmed. And now the channel is open. It's no longer opening because it has 3 confirmations. So it's usable. And let me check that it's also usable on the other side. Yeah. So now, yeah, I'm going to show a payment. So this payment, again, is routed with LND in the middle. So you have Electrum, LND, Electrum. So let's say that Bob wants to be paid, and Bob wants 1 millibitcoin. So the receive tab of Electrum now has 2 buttons. You can choose whether you want to be paid on-chain or using Lightning. So if I click on Lightning, I have a new invoice appearing here. So yeah, we also plan to update the QR code instantly, but here that's not the QR code of the invoice. That, I mean, yeah. Okay, so if I click on the invoice, then I see the QR code of the invoice. That's just a minor GUI bug. So I'm copying this invoice in the clipboard. And now, let me paste it in Alice's wallet. And I hope it's going to work. Let's send it. Yeah, okay, it worked. So this is payment between Electrum, LND Electrum. What you can see is that the history has changed in both sides. So you have a new transaction that appeared. You have this little Lightning icon, and it also increases the Lightning balance of Bob, and it decreased the Lightning balance of Alice. Alice paid 1 Satoshi of relaying fees, so that's why you have +1 here and minus 1.0001 on Alice's side. Okay, so let me just finish by showing you how to close the channel. So we have two ways of closing a channel. We can just close by talking with LND, so that's what we do here. So if I close the channel that way, then I see a new transaction in my history that is sending the funds in my Lightning balance back to my on-chain balance. And I need to mine this too. So let's mine a single block here so that this transaction is now confirmed. So it's taking like 1 second. Yeah, the delay is because you have also the Electrum server that is processing the blockchain, the Bitcoin D information, so that's why it's a bit slow. So now this channel has been closed, and you see that this transaction is affecting both the on-chain balance and the Lightning balance. Now, with Bob, I'm going to force close because I want to show you that too. So, well, okay, you can also see this window with details of the channels. So, yeah, it displays just technical information, like the list of HTLCs that you had and so on. So, force close is showing this question. It's warning you that the funds will not be immediately available because if you force close, your balance has this CSV delay. So let me click yes. And then the transaction is sent instantly because it doesn't need to talk with LND in order to force close. Okay? So the history now is showing, oh yeah, okay, this is a GUI refresh bug. I need to press F5, I guess. Yeah, okay. So it's showing this new transaction. There are two new transactions. The channel closure, and then there is a transaction that will be valid in 240 blocks. It's your two local output from your commitment transaction. So I'm going to mine. Let's mine just the first block. So if I mine this block, then they will be in the chronological order because currently, I mean, they are not. Okay, so the channel closure has been mined. You can see now that your Lightning balance has gone to 0, but your on-chain balance hasn't yet been affected because the transaction is in the future. Yeah, so let's do this. So I'm going to mine 239 blocks. And let's see. So it's going to take a few more seconds because now Electromix is processing all those blocks. Yeah, so now the transaction is has been broadcast because it can be broadcast now, but it is still not confirmed. In order to confirm, I need an extra block. Oops. And that's it. It should be confirmed anytime soon. Okay, so now you see the history with the channel open, channel close, and your two local output comes to you later. This is what happens if you force close. Okay, this is the first demo that I wanted to make, and it worked, so we are very lucky. Yeah, I think I showed everything from this demo. Did I forget something? No. Oh yes, I did want to show you. Okay, I'll show you later. So this is our. So this is if you have a commitment transaction output and you need to redeem those outputs. Some of them have to be redeemed before the CSV delay in case of a breach, and that's the ones that you see at the bottom. So if the remote party breaches, it means they broadcast a commitment transaction that is old. You need to claim those funds before the CSV delay. It's the two local output of their transaction and the HTLCs of their transactions. All the rest, you can claim it not instantly, but you're not in a hurry. I mean, you can claim it, you're not under time pressure. So I'm making this distinction because those three here, here, and here, those three type of outputs are the ones that you want someone to watch for you. The Watchtower should do that for you. And all the rest can be handled by the wallet. So our implementation handles all those outputs except those three in the wallet. So when you open your wallet, it's going to claim those outputs if your wallet is open. And for the tree that say before CSV, then it's going to be handled by a Watchtower. Yeah. Okay, I just wanted to, maybe this slide should have been earlier. Electrum is working with SPV, so that means the server, the Electrum server that you're talking to cannot fake a payment. SPV is a proof of correctness in that sense, but it's not a proof of completeness. The server can lie by omission. In particular, if your channel has been closed by the other party, the server can hide this, cannot mention this to you, okay? So this is a big, I mean, this hasn't been a problem so far for Electrum because we were on-chain, but with Lightning, if you have a channel open with someone and they close the channel, they force close, they breach, actually you want to know about that because you want to redeem those CSV funds before the deadline, okay, before the expiration of the delay. So that's where the idea comes from a Watchtower. A Watchtower is, okay, I mean, the other thing that I want to say is that Electrum users, usually they do not run a node all the time. So this issue of completeness is not completely, I mean, even if we had a proof of completeness, it would not be sufficient because if a user doesn't come online every day to check that the channels have not been closed, then completeness doesn't help. I mean, you also need to take some actions to claim the funds. So that's why we have developed this Watchtower thing in order. So the idea of a Watchtower is to delegate breach remedy to a third party. But yeah, there are different models. So everybody here must be familiar with the so-called anonymous Watchtower, where the Watchtower doesn't know you. So the transaction ID is split in half, and the Watchtower knows only half of it, and the other half is used to encrypt your blob of data. So you pre-sign some transactions that you send to the Watchtower, and in order to claim your funds, but this is encrypted, so the Watchtower doesn't know about your channels. This model implies that the Watchtower must store data for you forever, or at least they must pretend to do so, and you cannot really trust them about that. I mean, if I'm telling you that I'm going to store gigabytes of data for you forever, who am I?
They also can't claim all possible error conditions.
Oh yeah, of course.
You can still lose money, it's just you can't lose as much money in that one.
Yeah. Okay. The third thing is that they can, I mean, okay, my point is that they cannot delete data because they will not know that your channel has been closed. So if there is no breach, they are supposed to keep the data forever. And yeah, they can claim any kind of error conditions. They can be paid. I mean, okay, some people have considered that the incentive for paying the Watchtower is that one of the outputs of the transaction would be for them. But it's kind of weird to have the Watchtower incentivized for things going wrong. So I really think that a better, I mean, it's not, okay, there is this private Watchtower that I believe has more future, at least until we have L2, in the sense that it's private because it knows about your channels. So you're no longer anonymous, but it can delete your data if you don't pay them. So you can actually charge a monthly subscription to watch channels, and you can delete data if people stop paying you. You can also delete data because you know that the channel has been closed. So it's not It's a completely different model. It's more commercial oriented, and it might not, I mean, not everybody might like it, but I believe it's more doable, at least for the moment. So we have implemented that kind of Watchtower, the second one, and we are not going to release this as a service soon, but I want to show you how it works, because you can actually run your own Watchtower on your daemon somewhere, and you can use your code to do that. So the Watchtower that we have is using pre-signed transaction to redeem CSV outputs. And it can be local or remote, meaning, okay, it is by default local. If you open Electrum, you have a Watchtower that is handling those CSV outputs in your wallet. And you can also set it up so that it runs on a remote Electrum daemon. It's the same code base for both, and the remote Watchtower is just a mirror of the local Watchtower. The thing that is important to understand is that the local Watchtower does not require your wallet. So that means you can open Electrum, you can open your wallet in Electrum, you can do some payments, you can close your wallet, but keep Electrum running as a daemon. So your private keys will no longer be in memory, but the local Watchtower will use pre-signed transactions. So, okay, I'm going to give a demo of that. Can I close the window? Yeah, thank you. Okay. Oh. Okay, I did a mistake. Sorry. I should. I should have stopped the daemons that are running first. Oh, there is no daemon running. Okay, that's good. So what I'm going to do is set up 3 Electrum identities: Alice, Bob, and Carol. So Bob is a listening node, and so that's a feature. Okay, it's something that we are not going to enable when we do our first release, but we have already this. So Bob can actually listen and even forward payments, but it's not safe at the moment. And Carol is a Watchtower. Carol is going the Watchtower of Alice. So Carol is not going to have any channel open with anyone. It's just going to be a channel between Alice and Bob. And then Carol is going to watch the channels, the single channel of that is belonging to Alice. So this is done by setting configuration variables. So Bob will set the lightning listen variable to localhost and port. And Carol is going to set up host and port for her Watchtower. I mean, this is the URL of the Watchtower. It's communicating with HTTP. So then Alice will have to set up her Watchtower URL to the same host and port. And we are going to fund Alice, so that's the last line, okay? So I have a script that does this already so that I don't need to spend too much time typing. Okay. Now that we have done that, we have 3 identities set up with different settings. I'm going to start them as daemons. So I'm going to start Alice and Bob and to load their wallets in memory. So that's those lines. And Carol is going to run as a daemon. Carol doesn't need a wallet, actually, because it's a Watchtower. So again, I have a script that does that, partially at least. So I'm going, yeah, this script is starting all of them all three as daemons. I'm going to stop Carol because I want to see the output, the log of in the terminal. So I should stop Carol first and restart her like this. Okay. So now we have Carol running, and yeah. So this is the output of the Watchtower. This is the log of the Watchtower. Now on this screen, I'm going to have this interaction between Alice and Bob. So for this, I need only a single terminal. And I'm going to do what follows. So Alice is first going to open a channel with Bob. So I did it in the GUI during the first demo. Now I'm going to do everything in the CLI so that you can see how it works in the CLI. Again, I have those comments in the history actually. So first I need to know the ID of Bob. This is the first step is that Bob is going to, Alice is going to open a channel with Bob. So the ID of Bob is, where is it? Yeah, okay, this is, okay, so this is the ID of the lightning ID of Bob. So the public key of the node and the port. And then I will open a channel with 15 millibitcoins. More than that, actually, 150. So Alice is opening this channel. Okay, and now let's see the channels of Alice. So you can see that the channel state is opening, and I need again to mine some blocks in order to have it. So I'm mining 3 blocks here, and now let's have a look again at list channels. Still opening. I need to wait maybe 1 second. Okay, now it's open. Now the channel is open between Alice and Bob, and Alice pays Bob. So we have this request for 50 millibitcoins that is made by Bob, and Alice pays this request. Okay. Okay, maybe, yeah, I should have shown that the request is actually what you are familiar with, is this beg32 lightning request. So it was hidden in this variable. So lnpay means that we pay this request and it returns true. So it worked. Now let's see the channels again. So you see that the balance has changed. The local balance now is 100 millibitcoins. And Bob, yeah. Well, you can also use get balance actually. So you don't have all this information. Is this large enough, or can you read better like this? Okay. So the get balance command returns your balance on chain and on Lightning, and now Bob has 50 millibitcoins. Okay. So next step is that now Alice just paid Bob. Now Bob is going to prepare something nasty. So he's going to pay Alice, but before that, he's going to save the commitment transaction. So if I do Bob list channels, okay, I have I have this list of channels, and the channel point is here. So that's the funding point of the channel. I'm going to use this to save. I mean, I need to use this. This channel point in a variable like this, and now I'm going to extract the commitment transaction with this command get channel ctx. So we wrote this command mostly for testing. Of course, you might say it's bad because it gives the user access to toxic data, so-called. Yeah, we can talk about that later. Okay, let me copy this. This command is just going to extract the commitment transaction. Oops. Yeah, my mouse is behaving weirdly. Okay. So let's check. So this is a Bitcoin transaction. This is my commitment transaction as of now, and it's saved in this environment variable. After I did that, I'm Bob. So Bob is going to request funds from Alice. So 30 millibitcoins, like this. Oh, I forgot letter request, okay. And then Alice is going to request those funds, and Bob is paying Alice. So that's it. Okay, so now Alice has sent 50, and then Bob has sent 30 back. Alice is going to go offline. Okay, so now Bob is alone. And he doesn't know what to do with this channel. But he has saved a commitment transaction in the past that is more interesting for him than the current one, because it has 30 millibitcoins more. Just to have a look, I want to show you in the GUI what it looks like for Alice before the breach. Alice comes just online back for a second. So this is the history of Alice. We have the funding transaction of the channel, and then she sent 50 millibitcoins and she got 30 back, okay? Now she goes offline for good, and now Bob is going to do something nasty. So Bob is going to broadcast the commitment transaction of the previous, before he sent the 30, okay? And we're going to see what the Watchtower does. So the Watchtower log is here. I'm coming back to this window just to broadcast this. Okay, so this is a transaction ID. And now the Watchtower has done, okay, so this is it says it could not publish because it tried twice, but it actually has published the transaction, so it worked. The Watchtower has claimed the output that is CSV constraint. So let's mine a few blocks just to pretend that Alice comes back much later and that she cannot claim the CSV funds. How do I do that? Where is it? Okay, I don't remember the CSV. Let's mine 500 blocks, that should be plenty. Okay, so now Alice is going to come back online. Let's give the Electrum server a few more seconds just to catch up with those 500 blocks. Okay, so Alice comes back, and this is the history that she sees. So the channel has been closed, and you see that in the same block there is this transaction that is confirmed that has 49. This is the 50 millibitcoins that have been claimed by the Watchtower. That the funds that were in the channel on Bob's side on the commitment transaction that Bob broadcasted.
So it was Bob's to local.
Yes, it was Bob's to local, and the transaction that is not confirmed here was just broadcast by Alice's client, and it's the to local of Alice, so she can do that.
Bob's to remote.
Yeah. It's Bob's to remote. Sorry, because that was Bob's CTX. So this can be claimed anytime. So it's not the Watchtower that is taking part of this transaction. It's actually the wallet when the wallet comes back online. This transaction output actually already belongs to us. So we could actually not I mean, we don't need to have an on-chain transaction to claim it. We could also consider that it is part of the wallet. But I don't feel very comfortable with that because then it cannot be recovered from the seed. So that's why we have this extra transaction. It should not happen very often, and it's safer to send it back to an address that is actually recovered from the seed. So that's why we have this extra transaction. Okay, so I'm very happy because both demos worked. It wasn't working when we were trying 5 minutes ago. Okay. Yeah, thank you. Okay, so let me talk about what we are going to release. So there's no ETA. The initial release will not have forwarding. So we are going also, of course, to disable listening. The only channels that we are going to create are private channels. And Lightning will be enabled through this command line option --lightning that you saw earlier. That means that that implies that it will not be available in the binaries that we ship on Windows. It will just be for users who use command line. The reason why we do that is we actually don't want too many people to use it first because we want to hear back from bugs. And we want users to run their own Watchtower. We do not plan to have this Watchtower as a service that I described before until we are more confident. So the code for the Watchtower is public, meaning that anyone could use it and run a Watchtower as a service, but we will not do this in the first release. We might do it later, yeah. I don't know if I have time.
Could you show us the URL again of the talk?
Yes, sure. So it's electrum.org/talks/lightning/presentation.html. Yeah, okay, so I just wanted to say a few words about proof of completeness. So there are, I mean, the mainstream solution seems to be neutrino, BIP 158, 57, and 58. So with a soft fork, I mean that the filter would be committed to the blocks. There could be, I mean, there is another solution which would be closer to what Ethereum is doing, which is UTXO set commitment. So you create a structure, it could be a binary tree of all the UTXOs that exist. And so it's a Merkle tree, and you put the hash of this tree in the blockchain. So these are two solutions that can be used as a proof of completeness. But without a soft fork, what can we do? Neutrino has this other BIP. I don't know which one is which, but okay, Neutrino has this this idea that you can do a binary search. So you have multiple nodes serving the filters, and you can do a binary search to find out if they send you a diverging answer, then you can download the block and see which one is actually lying.
You usually can't do that anymore. The spec has changed.
The spec has changed?
Yeah, you can't do that anymore.
Okay. Why?
Because you can't reconstruct the filter from a block. You have to have the undo data. So you can't find out which node is wrong. You can just determine which block.
Why has it been removed?
It's because the version where you it makes the filters slightly more efficient.
Okay.
And if you were to, it makes use cases where you don't need that more efficient. So for example, if you were to go soft forking, then you would use the new version, or if you use it as a backing store for like rescanning for wallet, you would use this version as well. So for example,
okay.
Bitcoin Core Wallet will likely use the filters it has locally to do wallet chain rescans.
Okay, we should talk about that later, but yeah, well, okay. So, yeah, it's been removed from the spec. Yeah, okay. Yeah, I'm sure there is a lot of debate on that. I mean, if you also have a UTXO set, you can do the same, but it's a bit more expensive to create the proof of transition between the blocks. But so there are some papers about that. So I mean, the whole debate on proof of completeness is not finished. Yeah. Okay. Yeah. Well, that's it. That's the end.
We have a couple of questions from the live chat here. Nicholas said, I'm a little confused. Is Electrum built on top of LND or a brand new Lightning implementation? I assume the latter, simply using LND.
Okay, so the question is whether our implementation is built on top of LND, and no. The answer is no. We have a full Python implementation. I used LND in the demonstration in order to show that we can talk with the LND node, but I could also have used Electrum in the middle instead of LND. That's actually what we do in our test.
Okay, and another question was, will Electrum wallets automatically connect and pay the monthly fee to a public list of Electrum Watchtowers, similar to how they currently do with Electrum servers, or does a user have to manually do that? If you could repeat that.
Oh yeah, okay. The second question is about the payment model of Watchtowers and whether users will have to pay manually or whether it's automated. Yeah, if we do that, it will be automated. Currently, we are not focusing on that. The question is also whether we should wait for L2 or not with this implementation. It will depend on how fast L2 is available. Yes?
What was the thinking behind building a new implementation?
Well, first we considered using LND on, but yeah, it's not really very. LND has not been designed for that, and we also think it's maybe more interesting to build our own implementation. LND, you would need. I mean, we would need. We cannot safely run LND remotely. We would need to bundle LND with our software.
Well, I mean, even if you bundle LND or C-Lightning or something, you would need to make some modifications at the very least to connect to an Electrum server.
Yeah. It's not working in the same way.
So you plan this implementation to be fully bulk compliant, right?
Yes. Well, like I said, the first release will not implement forwarding, and it will not have nodes that are listening for connections. It will only have private channels, no public nodes. But maybe, yeah, in a later implementation, we can add that. That's not currently what we're doing. Yes?
Is there already a plan for channel creations? Something like a default channel to Electrum server or
Autopilot?
Autopilot, something like that, yeah?
Not really. I think we want initially we want to filter users. So we want the first users to be technically understanding what they are doing. We will simplify the user experience as we get more confident with this. But at the beginning, we don't want all our users to use this. So autopilot is not the priority. Okay, no more questions? Well, yes?
You mentioned L2. Can you describe what is the relation between L2 and why do you think it's important and whether you think it eventually will be implemented actually?
I don't know if it will be implemented. I mean, if it will be deployed. Yeah. It makes the Watchtower very different. So there is no huge disk requirement for the Watchtower. Currently, the Watchtower has to store, for every new commitment transaction, the Watchtower needs to store pre-signed transactions by the client, and that could be used in the future. So in the future, you don't even know what the transactions fees are going to be, so the client needs to pre-sign them for different fee levels, just in case. So that's a lot of data. And every time you do a transaction, you need to store this, or every time there is a fee update. It's even worse if you are a relaying node, because if you relay, then you relay potentially much more transactions per second, so then it's impossible. But for a light client that does not forward, actually the size of the data, the amount of transactions is kind of under control because it depends on the user actions.
Back to that question, can you go back to the Watchtower comparison public-private slide? I mean, so an interesting thing about L2 is that there are at least two variants of Watchtowers. One is that some random public guy running a Watchtower and does not know anything about you, basically, and he needs to store a lot of data and doesn't know what any of those encrypted blobs, he doesn't know which channels they correspond to. And the other one at the bottom, which knows exactly which blobs are for which channels. So with L2, there's an interesting change of mechanics and incentives here, which actually favors this bottom one, the Watchtower implementation that knows which blobs are for which channels. With L2, can delete the old blobs automatically.
Yeah.
So there's a storage complexity difference. The Watchtower that knows your channels with L2 only needs to store the latest commitment transaction to react by broadcasting the latest state. But the Watchtower that does not know about any of your channels does not get any benefits from L2. It will still need to store all the state. And that's another point why we would really want L2 to happen, because our model would hugely benefit from L2, the Electrum model, but the LND model would not at all. Interesting.
Yeah, that's a good point.
Could you repeat the point for the live streams?
Yeah, okay. So for the live stream, this point was made by an Electrum developer. So that's why he said our Watchtower. And he said that in the L2 model, the private type of Watchtower could be happy with storing only the latest commitment. So that's very interesting for us. Yes?
You mentioned in your Watchtower implementation that you still do pre-signed transactions. How do you handle fee rate information for those pre-signed transactions?
Can I handle what?
How do you handle fee rates on those pre-signed transactions?
We don't handle this yet, but what we plan to do is to pre-sign at different fee levels.
Okay, so then the Watchtower selects which fee it
Yeah,
uses at the
yeah. It can actually use RBF if it's smart, but it just multiplies the data by 5 or 10, I don't know.
Yeah.
Yeah. Yes.
Is there any plan for Electrum to come to mobile platforms like Android and iOS?
We already have an application on Android. It's just not supporting Lightning at the moment. So our Lightning implementation currently is only on the desktop, but the mobile version of Electrum is just a different skin. I mean, the inner logic is the same code. It's just a different UI.
So Lightning will come to Android as well?
Eventually, yeah. We haven't written the UI for that yet. Yes.
What's the default block time for the channels which you will be using and why?
Ooh, I don't know. Maybe Ghost43 can answer this question.
Well, I mean, 2 weeks would be the same choice, right? That's the protocol maximum.
I think we changed it like 3 days ago.
Well, it's 1 day now.
Yeah. Mm.
You also had a thing that it looked like you were accepting channels after 3 confirmations. Why are you only waiting for so few confirmations to promote a channel from opening to opening?
Isn't that in the spec? No?
But LND uses that also.
That's what LND, which is also
Okay.
Is it configured?
Yeah. I thought it was in the spec.
We'll scale with the size of the phone.
I thought it was part of the spec.
No,
Okay. Well, we can make it configurable. Okay. Yes.
Is there a chance for Electrum to come to iOS?
Ooh. If you want to help, we have a branch. But we are not working on that at the moment. Yes?
Not really related to the talk, but I think Electrum was the first to implement this pretty cool feature of amend by fee, or like you replace by fee, and then if you replace the current transaction if you have one in the mempool and like add another payment. No.
RBF.
It's RBF, but instead of just bumping the fee, you also add another output.
RBF batching.
Oh, yes. Yes. Yes.
Well, how do you call it?
RBF batching. It's in your preferences. You can set it. It's called like that. Yes.
Yeah, I think it's a pretty cool feature. Do you have any stats on how many people are using that actually?
No. How would we know?
Well, you look on the mempool and then like see if there's like transactions doing RBF and adding actually outputs.
Yeah, but it can be. I mean, we would.
Nobody else does it. So if somebody does it, it must be from there.
No, the wallet does that.
I don't know any other.
Okay, I don't know either.
Okay. It's cool feature.
Okay, thank you. Well, LND does it apparently. No?
Yeah, like from very reason.
Okay, any more questions? So then, thank you again.
I have a little gift from Hong Kong. If you're familiar with it, it's an NFC wallet.
Oh,
Tangier. Maybe you heard of Tangier.
Hong
They
Kong.
made this. Yeah.
I met a guy, what's his name again? Tall guy from Hong Kong.
Jonathan, blonde, tall guy, researcher.
No. Well, I don't remember. In Berlin.
Berlin?
Yeah, he was.
Very muscular guy.
Yeah.
Justin.
Yes, possibly. Yes.
Bold.
Yes. Okay.
Yeah, very impressive.
He's not with you, no?
He's with us. He's in our
Okay,
community.
I
He's,
see.
he's involved in the association. Bitcoin is
Ah,
King,
okay,
which is
okay. I see.
community organization, industry representation.
Okay.
But yeah, let us know if you ever drop by.
Okay, sure, I will.
You have lots of fans.
Thanks.
Thanks a lot for the talk.
It's very privacy.
Hi. What's up? Oh yeah, I must not lose this part. Okay, yes.
I
for
had
you.
to work on my slides. I hope
You-
they're fine now.
you
I
have
missed
to-
your talk.
Oh, okay. Yeah, I also prepared my slides like last minute, but
But I heard a lot of clapping, so.
Do you have stats on how many downloads for each operating system is initialized?
yeah, but I don't. I mean, you will need to ask some of